Hello all, welcome back to this channel, and today's video will be learning about a real world data engineering architectures. And to begin with, we'll be starting with Medallion architecture, which is most commonly used architectures in data engineering. And here we have data segregated in layers: bronze, silver, and gold, where it has a raw data in bronze and lightly transformed and completely clean data in silver, and in gold we have completely enriched business level data. And we have enterprise patterns. We'll be discussing about metadata driven patterns and configuration driven patterns and dynamic pipeline generation and schema drift handling and file validation. So to begin with, medallion architecture. So what is medallion architecture? Let's say you have a simple pipeline where you get the data from on-prem to cloud, and you have already more than 5 to 6 teams ready to refer the same data. So in that case, there might be a lot of discrepancies happening, and different team want the data at a different level. So instead of just creating a fuss of gathering, like taking their own data, creating their own copy, so we are just segregated data into 3 layers. So bronze contains a raw data ingested, like whatever the data is ingested, it's just as it is. So in silver we have filtered and clean data, and we apply all the slow changing dimensions whatever we have in this layer. And in gold layer we have like the downstream ready data, like based on the analytical or reporting or data science team, we add and prepare the data based on them in the gold layer. So to begin with, in the data like ingestion layer, which is a bronze layer, so we have no transformations, no cleansing, and no cleaning, and file stored as it is, and shift schema drift allowed, meaning the schema could be anything. And because the schema changes we will be handling in silver anyways, and duplicate records are allowed, and historical snapshots preserved. And we can expect data from different sources like databases, APIs, flat files, event streams, and IoT as well. So ADF role in bronze is we'll be using copy activity and mapping data flows and event driven triggers and on-prem. So bronze layer is not a different separate governance or separate kind of element. It's just your ADL is the blob container, which we consider it as bronze, meaning it only has uh, raw data. In here we can see the sink source. So source we have on-prem DB data, and in sink we have a container referred. So after this pipeline run, the data will be transferred into the sink, and we are just considering that sink as a bronze layer, and meaning it has the in every raw data whatever we have in the source. So we just did in the last video, and now we can see that like clean transform layer, which is a silver layer. In the last video we just stopped after we placed the data in the bronze layer, but in my previous video where I performed a complete data engineering uh, project, I created a complete medallion architecture over there, not just in a simple projects, even in high level enterprise projects or in actual data engineering projects, you always refer medallion architecture. So in this silver layer we clean the raw data, remove duplicates, apply schema corrections, handle CDC merge, so normalize inconsistent values and join related tables, sorry, and apply business rules. So silver is our trusted analytical ready data set. And so how we usually do is, so simply, so simply we just add a notebook. In this Databricks notebook, we get the data, we consider like for the source, we pull the data from the bronze layer, um, perform whatever transformations we need, and then store it in the another container, and we consider that container as a silver container. Similarly, for the gold as well, you repeat the same process, and the entire pipeline will be handled by ADF, and you can monitor the behavior of each and every activity of in monitor tab. So now, so in aggregated aggregation layer, and which is we call gold layer, we perform aggregations, of course, facts and creating facts and dimension tables and KPIs and curated data sets for reporting and Power BI semantic ready tables and feature tables for machine learning. So this layer is basically optimized, and meaning we prepare the complete data mainly for dashboarding, reporting, and decision making teams. It's a single source of truth, and how ADF fits in Medallion architecture. So it fits in every data engineering pipeline where the bronze, it gathers the data from different sources into one container, which is we consider as a bronze container. We ingest the data into this bronze, and we refer this bronze, and then we have a notebook, Databricks notebook, and then transform the data and place it in the silver, and from here we again take it, and based on the business logics we prepare the data and place it in the gold layer. So now coming to enterprise patterns, we have a metadata driven patterns over here. As you can see, one of the most important patterns today is metadata-driven ingestion. Instead of building one pipeline per table, we build one generic pipeline that reads instructions from a metadata table. Metadata contains the table names, file paths, and incremental column names, and watermark values, and file formats, and folder structure, and like load type, and it could be many more like schema rules. For example, and yeah, we'll be talking about the configuration driven ingestion as well. So it is similar to metadata, but in more detail. Like we also include like source connection, load frequency, CDC versus full load flag, and error handling rules, and file partition patterns, and row limit for testing. So what I mean is, like, as in the previous video we saw that we have more than 8 tables running. So we are not creating copy activity 8 times, but we created one generic activity, and based on the metadata, like data dynamically pulled from previous activities, we are performing that copy activity 8 times dynamically. So that also covers our dynamic pipeline generation, where we can have a dynamic content, and for the data sets, dynamic data set values and file paths we can gather dynamically, and we can also parameterize SQL, and we can also use a switch condition like dynamic pipeline. Let's say this lookup has no values pulled, and in that case, if the no values are pulled, we can switch it to a small trigger saying, sending us an email saying that no, there are no values, empty run, something like that. And we have a file validation and quarantine zone. Sometimes we might come across corrupted, incomplete, and wrong schema and wrongly named values. In that case, we skip them and we basically quarantine them, and then save them in another quarantine file path or somewhere, and then we save it in. We then only process the actual records. So corrupted and incomplete and wrong schema and wrongly named. So what you can do is, let's say in any copy activity, so if you go into settings, you have something called fault tolerance, like skip the incompatible rows and skip missing files, skip forbidden files, or skip files that are in which are invalid names. So you can either do it right over here, and you can refer the, let's say, logging You can refer the monitor and you can refer the logs and find what values are missing. I mean, what rows are skipped, and you can get the data from there. Or you can, in Silver Layer, you can just get the data as it is, and Silver Layer you can create a quarantine file path, and you can process the raw, I mean, successful and clean data into Silver, and you can pass the like bad data into the quarantine file path. So likewise, you can just check, and some validation step may include like number of rows and column count check and schema matching and file size checks and duplicate file detection. So that's it for this video, and thank you for watching.